Strong, and this is my physics project on bike gears. In 1900 to 1930s, the hub gear was the first gearing system created. It was very hard to change gears while pedaling. The gear were closed off, so repairs were difficult, but because it was closed off, it was hard to break. In 1937, the original derailleur was created. This name comes from the chain derailing or shifting from one sprocket to the next. In order to shift, one had to pull a lever next to the wheel while riding the bike. In 1949, the Grand Sport was created. It was the first modern derailleur, and it was created by Campagnolo. It is still commonly used today, and this gearing system is inspired loosely on that design. It uses cords and pulleys to change gears, and there's pretty consistent shifting. Cyclists had to use feel and sound to know how to change gears properly. In 1980, index shifting was created. All individuals have to do is flick a switch, and it shifts chains to lower or higher gears. It is more commonly used, and it is the basic one that most people use. In 2020, electronic shifting was created. It is light and there's less wear and tear because there's no wires or cords, and there's high level precision and smoother and more reliable shifting. You have to charge its battery, and there's less maintenance involved, but if a wire breaks, it can be very expensive to repair. Reasons for advancement are the hub gear was the first bike that we know of that was more than just a single speed. The simplest 3-speed hub made it so cyclists didn't have to sit over top of the wheel to move their bike like a pennyworth, which ultimately made cycling a lot better and efficient for that time. The original gear shifters were awkward and unreliable because you had to take a lever placed behind you to shift while riding. It was very hard to do this and ride. This led to inventors using cords and pulleys to pull that lever instead of physically moving it. But as advancements were made, they slowly became better and almost to the point of perfection. Now our gearing systems can have more than 9 speeds to make it easier to go up hills and other steep grades. By changing to a harder gear, you can also go faster down hills and on flat ground. Measurement. Determination of size or magnitude of something. Thermal energy transfer. There is thermal energy between the chain and the cog. Friction occurs when changing gears as well. There's also friction between the tire and the ground. Energy conservation. By changing to an easier gear when going up a steep hill, you're conserving energy. When the back gears are small, less energy is used because for each rotation of the front cog, there are many rotations of the back one. Transition of force and motion. If a cyclist uses 113 newtons and goes 3,700 meters, how much work does the cyclist do? Work equals force times distance. So work would equal 113 newtons times 3,700 meters, which in scientific notation would equal 4.18 times 10 to the 5 joules. Fun fact, if you divide work by time in seconds, you will get the watts, which is the commonly used energy source that cyclists use. Forms of energy. Kinetic. The cyclist generated a kinetic work of 1,378.67 joules. If the cyclist weighs 78 kilograms, what was their velocity? EK equals 1 over 2 mv squared. So velocity would equal square root of 2 times 1,378.67 kilograms meters squared per second squared, divided by 78 kilograms, which would equal 5.9 meters per second. Efficiency would be output over input times 100. Bicycles have an efficiency of 52%.